Hello again, we're back to talk about section 3.5. This section is one of our shorter sections. I think it has a shorter homework assignment, so hopefully it goes very quickly for you. The section is on graphical transformations. Once again, something that I feel like is part of our review because it all comes from algebra. So in this section, we will spend a lot of time talking about or looking at graphs, but also seeing how these graphs are really just a slight transformation of a graph we may be familiar with. And so it helps us maybe understand the actual function that's written down to describe a graph if we understand these transformations in their entirety. So let's take a look. It's really just going to be a set of these different rules that we can use to help us understand graphs better. So let's first look at some different graphs. Here's two graphs. You might notice this guy right here is x squared. The only difference between this guy and the guy up here is that it's raised up 3 points. That's it. And you can see it right here if you actually look at the equation. It's x squared plus 3. So that should tell us something. It's when you have a plus 3 right there, it means, oh, you just raise a graph up 3 positions on the y-axis. Or just 3 in general. Let's see what that means then. So here's an example, right? Vertical shift up is exactly that guy we were talking about. You use the graph of x squared. It's our baseline graph. And we can obtain the graph x squared plus 3 by doing this shift. One way that we'll frequently talk about this is saying that we could plug all these points into a calculator and see, look at consistently, it's just 3 higher at each one of these positions. 4 is 3 greater than 1, 3 is 3 greater than 0, and so on. So that just gives us exactly what we saw right there. We can also, though, and probably not a big surprise, shift things down. When you shift things down, that's really just going to mean that now you're subtracting. So once again, using x squared as our base, we will look at x squared minus 4. And now you'll notice that everything is exactly 4 lower for the other graph. The graph in this case of h of x. That should be an h right there. Or that should be a g. We could change that. But notice here's our x squared, and the whole thing just gets shifted down 4. We can also go right to the right or the left. And like I said, these ones I'm going kind of quickly because I feel like these are ones you probably have seen before. And we're giving this, in this case, really just one example, and you don't have a lot of homework. It's not an emphasized point, I would say, in our class. So now if we want to go left or right, well, you know, if you go to the right, now this may seem counterintuitive. You might have remembered this too because it is counterintuitive. To go to the right, you actually subtract. But notice what you're doing. You're subtracting inside the parentheses now, right? You're actually squaring this whole thing. So that is a very key component of this. So, but what you'll see is just by graphing the points, if you're not convinced, you can look inside of here and say, what's happening? Well, this point 4, it seems like it's happening at a location 2 to the right of where it happened before. This 0 was shifted down there. This 4 is shifted here. This 16, you can probably guess would happen if we had 6 on our graph right there. And in fact, here is our shift. Here's our original x squared, and here's x minus 2, the quantity squared, shifted 2 to the right. We can also go to the left, and the left just happens by adding things inside those parentheses, or really I should say, you have whatever operation you're performing, you perform your operation on that too. So it's inputting x plus 4, x plus something into the x location. So it would be f of x plus 4 right now is what we really did. It is what gives that g function. So we go inside of there, and we see that we've shifted 4 to the left. Ta-da, right? In general, here's all of our stuff done. We did our shifting vertically. We did up when we had a plus. We did down when we had a minus. But the key thing to remember is that the up and down shifts are due to addition or subtraction. When it's outside, in this case I'm saying the parentheses, but really, and it really is, I guess I could say the parentheses right there, right? It's going to be f of x minus k, or f of x plus k. But now, if we're going to do a shift horizontally, either left or right, then that is going to be when something is inside our parentheses right there, okay? So keep that in mind. That'll be really helpful. Of course, we can combine all this together and have something with multiple shifts. So you look right here, you're like, oh, there's a plus 3. I know I'm going to shift a certain way. There's a minus 5. I'm going to shift a certain way. So if we perform these, we say we start like with an x squared. We know that was our baseline graph. We draw that one first, and our first thing is going to move it 3 to the left because we have a plus 3 right there. So we go 1, 2, 3. We move it to the left, and now what's our last one going to be? It's going to be to shift it down 5, right? And so we subtract 5 and move it down, and there we go. Isn't that nice? Yay. So we can do multiple shifts on one thing, and even though this may look like a confusing graph to look at, it really isn't that bad. Now there's other things you can do with a graph. Instead of just like moving up, down, left, and right, you can also stretch or compress a graph. And the vertical stretch is really something that I think makes it be like a more narrow graph, or a, think of it this way, if I draw the picture with this, right, it's sort of, that's a very narrow graph versus a wide graph if I'm just talking about x squared. So in this case, we're talking about the absolute value of x, which is a graph that looks like a V. And so we're going to either make it more narrow or more wide. So let's see what happens when we multiply by 2 on the outside. Okay, let's see what happens. So all I have to do is plug these things, plug the equations in, and test some values and see what happens. Well, look, it has a value that's higher than that one. A value is higher there too. It's consistently higher by a factor of 2. Well, then that should tell you if it's higher, then it's going to be more narrow. So you can see the blue line is more narrow than the original absolute value of x function. So you get a narrower or a stretched out graph by multiplying on the outside. And this is a thinner graph is what I called it. Now you get a wider graph if you multiply by a number that is less than 1 on the outside, between 0 and 1. We're not talking about negatives here, between 0 and 1. So let's see the results here, and notice consistently this number is 1/2 the size of the one on the left, right? Well, 0 doesn't matter. And you can see right here the blue is a wider graph than the black. And that is, we're compressing the graph down. I sometimes call that smushing the graph. So here we have these two guys. We also could talk about a horizontal compression, and that's going to be something that went on the inside right there, okay? So this would be inside the parentheses. So once again, we have these compressions and stretches are due to multiplication that's outside the parentheses, and you have a horizontal if you are inside our parentheses as we described it before. So just some general rules. You can test this on your calculator too. That's a really good thing to do. Test some basic functions, like square root of x is a good one to test. All right, so let's look at compression and stretching on here and just see what would happen based on those rules we looked at. So here is our function. Maybe it's some trigonometry that we'll see in the future. I don't know. Well, maybe I do know. But so we have this graph right here, and we're saying, well, if we multiply by 2, what will happen? Well, that it's going to be on the outside, so it's going to do something. It'll be vertical, that's what we want to remember. And you can see it's a vertical stretch by 2, because now instead of just going to 1 for a local maximum and -1 for a local minimum, it goes to 2 to a local maximum and -2 for a local minimum. So it's been stretched. It still ends at 3 pi and everything there for this same section of graph. But now if we multiply on the inside by 3x, remember this is going to be a horizontal compression or stretch. And so if you have anything bigger than 1, then you're going to be compressing this in or smushing it in. So there we go. And you can see we've done a horizontal compression by 3, and you can see where it used to go all the way to 3 pi, now it only goes to pi, right? All that stuff was smushed into this little tiny spot. But it still goes, it's not like went any higher or lower. It still has a local maximums at 1. At the local maximum values are at 1 and at -1 for the local minimum. So very interesting stuff. Now let's another thing you can do is you can reflect things about an axis. So if you graph this function, -x², that's just the same as x², but it's been flipped over the x-axis. So not such a big surprise, right? The negative is sort of like a mirror effect. We can also reflect, it's just multiplied by -1. We can also reflect about the y-axis. And that's going to be when we plug something on in this case, it's almost like the inside of the parentheses. So this would be the reflection of the square root of x. So you can see right there, it's just a reflection about the y-axis. not a big surprise. So to summarize all these things, here's just these charts. It's really just saying exactly what we said before. It's a summary of techniques. I'm really not going to talk about them because we did each one of them. You can use these. You might even want to write down the summary of techniques just to aid you in doing your homework, so you have it right next to you while you're doing it. But what we are going to be interested in doing is combining these techniques to be able to either identify a graph or to, and try to see what happened to a graph if we perform different operations on it. So we're going to say, let's take the v-shaped absolute value of x and let's shift it 2 units to the left. And we also have to write down what that means to the graph. So we shift it 2 to the left, and we get this new graph, and we know that when you go to the left or the right, that's going to be inside the parentheses. I know there's no parentheses here, but see, that's why the x plus 2 is on the inside. Now we want to go up by 3. That means we're going to add on the outside of the parentheses. So it would be a plus 3 on the outside, and we see that it shifted up on the green V. And now finally, we want to reflect about the y-axis. You might remember just a moment ago we did that. It's almost the same as something familiar. I don't know if you remember. This is going to be, it's the y-axis, not the x-axis, so we want the negative on the inside. So replace x by negative x is all we have to do, and we get it reflected about the y-axis. So that is our graph. Let's do one more, and we'll be done with this section. Now we're saying, oh, we have this crazy function. If we know what its base function is, then we can graph it because we know the operations. So the base function here is the square root of x. So that's our base function. That's our step 1. Now we're going to say, what's our next step? What can we do to make this easier? Well, we could instead say, well, I know that x, you might say yx plus 1. Well, we'll get to that in a second because we're going to see some other stuff happen here. But if I plug x plus 1 in there, then I'm like, well, I know that all that's doing is shifting it to the left by 1. Now, I'll actually plug a x. I'll put a negative x in there because I know I want to get to 1 minus x. If I do a negative x, that means that I reflected about the y-axis. We just did that a second ago. Well, that was interesting. It just flipped my graph from this direction to this direction. And finally, all I have to do is add 2, which I know is going to shift it up 2 slots. And there we go. So instead of starting at 1, 0, sort of as our starting point, it starts at 1, 2. And that's it. That is this whole section. I'll be back with, I guess, Chapter 6 and Section 6.1 very shortly.